Hello class, welcome to lesson 19 where we're going to be looking at how to compare rates using different models like tables, graphs, and equations. We're leaving double number lines out of these notes, however we will be working with double number lines in class and how to make use of data written on double number lines when we're comparing it to tables, graphs, and equations. Now I'm going to zoom in, those of you who are copying on a small screen. Here's the first half of your notes. Probably want to pause it now. Here is the second half of your notes. Now would be a good time to pause it. So just a quick little housekeeping piece. I don't know if you've noticed, but this is the Q stands for question, the T stands for task. I'm going to start to try and abbreviate those headings just to save space on our notes and save you a little bit of time. Question we're searching to answer for is, how can I compare rates when displayed in tables, graphs, and equations? So we compare data all the time when we're looking at prices of things that we want to buy, or how long something is going to take and what's the best way to do something based on how long it'll take, how much energy we're going to expend doing a certain thing. Really, we compare data all the time. So that data, however, isn't always displayed the same way. Sometimes it's displayed in a graph, sometimes it's in a table, sometimes it's an equation, sometimes it's in a double number line that we're going to look at. More than likely, most of the time it's in words or a word problem or written out in a sentence. We're going to learn how to compare those rates today. And it's actually not all that complicated. The task we'll perform in order to do that is to identify the values being represented and then compare. So all of these different methods of modeling data can be broken down into what is their value. And when I speak about value, I know that that word kind of gets tossed around a lot. But in this sense, the value is referring to the ratio written as a fraction. Now, we've repeated this over and over in class. I've said it and you've repeated it. We've worked with it a lot on classwork and tests. Hopefully you understand that the value of a rate is the same thing as the value of a ratio. Just write that rate as a ratio, turn it into a fraction, and then simplify it. Once it's simplified with a denominator of 1, so when we find the value, the denominator of whatever the rate is will be 1. And then once the denominator is 1, we can compare whatever the numerator is. If we have 3 ratios in a row, they all have a denominator of 1. I can't really fit a third one on here, but let's kind of go over here. We have 3 ratios with a denominator of 1. All we have to do is compare these numerators, and we have an easy comparison. So the point is to get this denominator to 1. And the way that we've communicated that is to just find the value. So that's our goal. Find the value of each rate and compare from there. Let's get rid of all this mess that I created. Okay, now we can take a look back at our notes. So I've started us off with an example of an equation because a lot of times that's sort of the most tricky one to deal with. So let's take a look here. We're talking about Sam, and he's a soccer player. So if Sam can score 3 goals per game, what is the equation? So we are trying to write this information of goals per game, 3 goals per game, in equation form. Now remember, an equation has to have, I mean it's in the name, it has to have an equal sign. Okay, so we have our equal sign. Then it has to have 2 variables. So we have GO for goals, GA for games, and then we have, like always, our multiplicative constant. Okay, so we have equal sign, the variables of the two units that we're working with, goals and games, and then we have our multiplicative constant. So if we are looking at this ratio, and I want to get rid of this extra stuff that I made, okay, and we'll zoom back out a little bit. We know that if he plays one game, then how many goals does he score? We have 3 times 1, which is 3. Pretty simple. Now, to make sure that this equation works, let's test it one more time. Let's say instead of one game, let's say he plays, a whole season might be 16 games. Let's say Sam plays 16 games, so we're putting 16 in for games, the GA. 3 times 16, we have 16 times 3 is going to be 48. So he plays he plays 16 games, scores 48 goals. Now, we know that if we wanted to find the value of this equation, we want to get, like I said, we want to write it as a fraction. Oops. We want to write it as a fraction and then get 1 as the denominator. So if Sam scores 3 goals per game, that means he scores 3 goals per 1 game. We just assume that 1, which means our ratio is going to be 3 to 1. And if we write that as a value, we know, hopefully by now, that a value is just whatever that ratio is written as a fraction. So 3 to 1 is just going to be 3 over 1. Now our next example, where we're really solving our task, is right here. It says compare all 3 types. The rates we're talking about are going to be goals per game, similar to the Sam example, but different. We're talking about 3 different people: Steve, Rick, and Mike. They all play soccer, and they all have 3 different rates of goals per game, and they are displayed in 3 different ways. Obviously, you see Steve here. He's using a table. You see that Rick is using a graph, and Mike is using an equation. Like we said at the beginning, in order to do this, we need to identify the values being represented. So let's come down here, look at each model individually, and see if we can't figure out the value for each person's goals per game. Looking at Steve first, we've got our beginning ratio of 2 to 6. So 2 games, 6 goals. Now if we wanted to simplify this ratio to find its value, we'd write 2 games over 6 goals. And then we know that we can simplify 2 over 6. If we divide them both by 2, we get 1 over 3. So we know that Steve scores 3 goals, since this is goals and this is games, 3 goals in 1 game. Okay, not too bad. It's pretty good average if you ask me. Let's move over here to Rick. We see Rick's first ratio is, oh, you can't see the label of the graph, games down here. So Rick, if he plays 1 game, he scores 2 goals. That one's not too bad. We actually already have the value there. We have 1 game, 2 goals. Pretty simple. So if we're writing that, we see that for he scores 2 goals in one game. Not too bad. Then we come over here, and for our previous two examples, we are trying to get to the point where we have one game. We want to know how many they score in one game. So here we reduce the 2/6 to one game. Here, to find the one game, we looked along our x-axis, which is games, and found the 1, found its corresponding y value, which is 2. So we know one game. Over here, we still want to get that one game. Since we're working with variables, we can just go ahead and plug in the number 1 for our games variable, because that'll give us an equal denominator on all of them. So we've got one game. If we now solve this equation, we have 4 times 1 equals 4. So what this says, if we plug in the number 1 for games, we get the number 4 for goals, which means that he scores 4 goals in one game. And I have all of that written for you down here on the bottom. And well, you have it written too in your notes if you paused it. We'll get rid of all this stuff. Alright. Sorry, you have to wait to watch me get rid of all this stuff. Okay. So, here is what we're looking at. We've got all of our values written down here. We have so each of these means one game. So in one game, Steve scores 3 goals. In one game, Rick scores 2 goals. And in one game, Mike scores 4 goals. So, dun, 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 Mike has the highest rate. The point is, we have to get them with the matching value of 1 so that we have similar things we can compare.